Let's look at this D flip-flop connection where Q bar is connected to the input D. We want to look at the maximum possible clock frequency into this in terms of the propagation delay, setup time, hold time, whatever the timing constants. So let's start with Q being 0 and Q bar being 1. So the D is getting, with the first clock D is getting 1. So Q is now will become, after that will become 0, and this will keep going on. So this is the wave shape of Q without any, assuming any, there is no propagation delay. So if there is a propagation delay and we consider the setup time, what happens? Let's see. Let's assume that with the propagation delay, let's say this one goes there and like that keeps going. So this much is the propagation delay, T P low to high in this case, and again for the second one it will be high to low. So this much will be TP high to low, so depending on which one. So this is the propagation delay, and then there is, before the next clock comes, we also need to compensate for the T setup time, which has to be, of course, like there. So setup time means before the clock edge comes, the input cannot change for a while, so this will has to be, the setup time has to be greater than the setup time. So we can see this width, when we increase the clock frequency, this width will start getting smaller because f is 1 over t. So this width with the increasing frequency will get smaller, but this has to be bigger than a minimum value, and that minimum value is, so the TW, if we call it, it has to be greater than the TPLH plus T setup time. This is the delay and this one is the setup time, so the addition of these two has to, we have to accommodate before the next clock comes. So this one or TPHL plus TSU, as we saw in the last video, these two can be different, so whichever is bigger has to be there. So let's say TPHL is 10 nanosecond, just for example, and sorry, TPLH is 12 nanoseconds, so we have to take the bigger one. So that one plus setup time, whatever it is, let's say 8 nanosecond for a certain value, so 20 nanosecond will be the minimum width of this one. So this is how the maximum clock frequency is restricted, because inverse of this will be the frequency. So yeah, this one is just an example to show how we can find the how the maximum clock frequency for a flip-flop is restricted by the propagation delay and the setup time.